Hey guys, let's talk about word problems, real life adventure problems. I'm going to do one from each section here just so you guys have something to fall back on to look at because I know you may or may not have had a lot of time to go through this yesterday. And again, the key here is remember the problems are easy and maybe even guessing and checkable or trial and error simply so that you can get used to how to write the equations. So the answer here is actually writing the equations is actually almost more important than writing the equations. Now, a couple of things. Remember to subscribe and smash that like button. No, don't worry about it. So anyway, let's take a look at. Now let's do number 2. So the sum of two numbers is 52. These are, if you look at a problem like number 3 with Greta and her cats and dogs. Cats and dogs, a lot of times people have an easy time doing because it's two distinct things. The number ones are sometimes harder for people because it's like, well, what do I do? So this is a little bit different. Sum means plus, is equals. One number is 12 more than, so that's plus than the other. So in terms of setting some of this stuff up, again, remember, we're translating English into math. So the first thing that I would do is that I would say, okay, two numbers. I'm going to call them x and y. So I have a sum of two numbers. Those two added together, x plus y is 52. Well, that seems easy enough, hopefully. Now, this is a little different than the way I did in class. I know in class we kind of pull stuff out, and we'll talk more about that in the next two examples. But for something like this, it's pretty straightforward, I hope. Now, for one, the part that throws people is on the second one. It says one number is 12 more than the other. Which number? Does it matter if it's x or y? In reality, no. Because since we're only talking about two numbers, one number, so like here, if I tell you x plus y is equal to, I don't know, let's say 10. This is an aside. This is nothing big. This has nothing to do with the problem. If I told you that x is 4, what does y have to be? Oh, you get 6. Great. What would happen if, instead of doing that, I told you that the other number was 4? So this is 4. Well, the other number is forced to still be 6, because to find it, you would subtract 4 from both sides, right? So because of that, what ends up happening is that when we do a problem like number 2, it doesn't matter which number is the bigger one, because the other one will automatically compensate for it. So in this case here, one number is 12 more than the other. So here's the other number. I'm going to go 12 bigger. So now you've got this wonderful, great system of equations, prime for substitution, and away you go. Okay? So then, blah, blah, blah. I'm going to take this, plug it in here. I'm going to rewrite them both over here because rewriting is always nice and helpful. So the x becomes y plus 12. I have the y and the 52 from the original problem. And then you just combine like terms. And again, this is something we spent a good week and a half on, pretty much. So hopefully this is not terribly new for you. So one of my numbers is 20. And then you're going to find the other one. You're just going to plug that in. So I know that x is equal to, I've got y plus 12. Y is really 20. So x is going to equal 32. Now, as we talked about in class, the communication of the final idea is pretty important. So I would just summarize this because, again, you don't want your boss questioning what's going on. You're just going to say the two numbers are 20 and 32. No ordered pair needed. No x equals y equals. A sentence to explain what's going on, to show that you're the intelligent person that we thought you were. Again, remember, pause whenever you need to. That's the other nice thing about doing this. Let's take a look at, how about Mike? Oh, we could do Super Hungry John. Let's do number 5. John decides he's super hungry. Now I'm going to actually block off the rest of this so we've got better room to work. So give me 1 second. Ta-da, that was easy. Okay, John decides he's super hungry, wants some ice cream. Ice cream parlor, ice cream cones cost $1.10. Sundaes cost $2.35. John and his buddies visit the parlor, and they bought a total of 172 cones and sundaes for $294.20. Holy buckets. So how many cones were sold? Okay, so that's what we're trying to find right here. If I could actually get the pen to work. There we go. Beautiful. So how many cones were sold? Great. So we know how many cones were sold. So that's what we're going to actually find. So the two things that we know about this is that they ordered cones and sundaes. So we have the total number of what they sold. And we also know the total cost. The total number was they had 172 is the cones plus their sundaes. And by the way, yes, that is how you spell ice cream sundae. The cost was $294.20 is the cost. So, and again, now watch this. So you're going to have the cost of the cone. Oh, wait, we do know the cost of the cone. How much did each cone cost? So for each one of those cones, we have to pay $1.10 times the number of cones plus $2.35 for each one of those sundaes. You got to scale how much each of those things cost. It's kind of like if I had 10 $5 bills, you wouldn't say I have $10. You would say, oh, 10 times 5 is $50. Same idea. So now that you've kind of organized this into English, now let's translate it into math. And remember, the word is always going to be equals on these. So we've got 172 is equals. Now, we don't know how many cones or sundaes are. So we're going to put in, I'm going to go C and D because S is a really bad variable to use because it looks a lot like a 5, to be honest. So be careful of that. So I'm going to go C and D. And then the same thing down here. So now I've got $294.20, and that's going to equal $1.10 for each one of those cones, plus $2.35 for each one of those sundaes. So I'm going to use D and not the S that I almost made. And now you have a system of equations. We've got this beautiful system right here. That should be all. Ooh. So I'm just going to rewrite it down here. But now you're going to go through and solve it. So I've got C plus D. I have 1.10C plus 235D equals 294.20. Substitute it. That actually wouldn't be a bad way to do it. You could do elimination. That also works. Whatever floats your boat, as they say. All right, one more. And I'm going to trust that you can solve this out. So we're going to go one more. Bam. Let's see, we could do pizza. We could do Nike store. Ooh, clothing's always good. State fair is always fun. Going to the mall. Malls don't exist anymore, so we won't do that one. So let's do 11 is a lot like the problem that we just did, so I'm going to skip that one. 10. That's kind of like the first one. Yeah, actually, maybe we'll do 10. Maybe Mr. Hayes will stop talking to himself. These are all kind of similar. So let's take a look at the Nike store one. Just for grins. Nike store, 4 pairs of shoes. Oh, okay, so right here. So we've got 4. Now, I'm not going to write it out quite as much as I did the last one. We're going to kind of merge it into, actually here, pairs. Because let's face it, why write more than we have to? Actually, you want to write more than you have to initially. But see, you've got pairs and pairs of shorts and pairs of shoes. So it's 4 shoes, 3 shorts, cost us $280. Ooh. 4 times the cost of shoes. So actually, this would be 4 times the cost of shoes times $3 times the cost of shorts. Would be $280. Shoes cost $35 more than a pair of pants. Okay, this is the one. Let's talk about this over here. I've got shoes. I've got pants.